Hi, in this video we're going to look at another very famous and important type of philosophical argument, the inductive argument.
John Stuart Mill on his own free will, on half past shandy was particularly ill. Later they say he could sing it away. Half a grade of whiskey every day. Aristotle was a bagger for the bottle. Hobbes was fond of his dram. And Rainy Descartes was a drunken fart. I drink, therefore I am.
So, as we discussed in video 3, in philosophy, well certainly in A-level philosophy, there are three major types of arguments that we need to know about. The deductive argument, covered in the previous video, inductive argument, covered in this video, and abductive argument, which will be covered in a future video. Now, also as noted in the previous video, whilst on the A-level syllabus, certainly those three types of arguments are distinguished, it has been something of a controversial issue in philosophy just how many fundamental types of argument there are, and some people argue there are just two. A popular suggestion has been that there's just the deductive and the inductive argument. David Hume, famous philosopher, is associated with that view. Have read that actually some people argue that abductive argument, this argument should be seen as the sort of more prominent and important one, and inductive argument perhaps could be a form of that type of argument. But we don't really enter into those debates, or we don't need to succeed in A-level philosophy. So we're just going to consider, as per the syllabus, that there are three distinct types of argument. So today we're going to look at the second of these, the inductive argument. So we'll begin with a quick recap of the definition of an argument, hopefully familiar to you by now. We recall that an argument is a set of propositions put forward to establish the truth of a further proposition, and also that we have these special names for the set of propositions used to establish the truth of that further proposition, and for the further proposition itself. We call the set of propositions the premises, or sometimes the reasons, and these are put forward to establish the truth of our conclusion. And also, it's good and productive just to review the definition of deductive argument as well. We can use that to contrast with our definition of inductive argument. So from the previous video, a deductive argument is an argument put forward to establish its conclusion as certainly true. And we said that it may in fact fail in its goal. It may not establish its conclusion as certainly true. There may be various flaws in it. It may be unsound. It may be invalid. But the goal is it's put forward with the intent to establish the conclusion with certainty. So the conclusion will follow with logical certainty, and we are sort of compelled rationally to accept it. So now to look at the main subject of this video, inductive arguments. How about a definition for these? Well, a typical definition that is often given is that an inductive argument is an argument put forward to establish its conclusion as probably true. And often this serves as the full definition of this type of argument. And this works very well if you're only dealing with two types of argument. If you consider perhaps that there's only deductive arguments and inductive arguments, then you have this nice contrast. The deductive arguments, those which establish the conclusion with certainty, and the inductive, those ones that establish the conclusion with probability. A slight complication comes then, however, when you consider abductive arguments as well. And in the case of abductive arguments, not to be fully covered in this video, the conclusion of these arguments also follows with probability, much like the inductive argument. So we'll need a little more to establish what we mean by an inductive argument, and we'll add this below. So whilst it is true that an inductive argument is an argument put forward to establish this conclusion as probably true, we will wish to add another element to that and sort of be a bit more specific about what an inductive argument is, especially in light of this issue of what an abductive argument is. And so to complete our definition, we'll just add this here, which is that an inductive argument is a generalization based on past experience, and we'll go on to see how that works. So to review then, an inductive argument is an argument put forward to establish its conclusion is probably true, and which is a generalization based on past experience. So inductive arguments are generalizations based on past experience. So given this, we can outline the general form of inductive argument, the general form they call all follow. They may not transparently follow this form, may not necessarily be obvious, but they can, with analysis, if they are genuine inductive arguments, you can put them in this form, you can convert them to this form, and it's useful to think about them in this form. So they have this same basic form, which is the following, and we can look at some examples of how this is going to work. All previously observed x's were y's, therefore all x's are y's. So all the x's you've seen sort of in the past, previous observations, they were y's, and so we're going to generalize based on that and say, well, all x's are y's, even ones that we haven't observed yet, or the ones we didn't observe in the past, and so on. We're generalizing. These are all they follow this same observed pattern that we've noted. So this is what we mean by a generalization based on experience. That's a little abstract. Let's see how that's going to work in practice with some examples. So for example, all ravens I've seen are black, therefore all ravens are black. A very simple example of an inductive argument. Just one premise in that argument, all the ravens I've seen are black, and the conclusion being that all ravens are black, as we have there. Notice that this does fit the pattern of the generalization from past experience. In this case, based on our previous generally outlined form, X would be raven and Y would be black thing. So all previously observed ravens were black things, therefore all ravens are black things. Now we can note with this example another feature of the inductive argument. We mentioned earlier that the conclusion in an inductive argument, no matter how strong the argument is, it only follows with probability, and someone advancing an inductive argument can only ever hope to draw their conclusion with probability and measure a probability. If you recall the deductive arguments we were looking at, if they're valid deductive arguments, then if you accept the premises, you must accept the conclusion. If the premises are true, the conclusion must be true. So the conclusion follows with certainty, we say. But in this case, if we look at the inductive argument, we can contrast this with those deductive arguments, because you could accept that all the ravens that I've seen are black, and yet you could reject the conclusion. You could say, well, yeah, even so, some ravens are not in fact black. There may be some out there that are white or something like that, or green, or any color of the rainbow. And so even accepting the premise, even without any flaws in the inductive argument, we don't necessarily have to accept the conclusion here. And to look at another example, a stronger argument, we'll come on in a moment to look at the relative strengths of these arguments. All previous observations of water boiling took place at 100 degrees centigrade, therefore water boils 100 degrees centigrade. Again, this fits our X and Y pattern. In this case, X stands for water boiling event, and Y event 100 degrees centigrade. So all the water boiling events were events at 100 degrees centigrade in the past, and so we generalize based on that to say that in general water boils 100 degrees centigrade. This example here obviously also allows us to see a possible use of inductive arguments. We may wonder why even use these arguments if they can only reach their conclusion with probability. Well, surely we should go for deductive arguments. But we can't always necessarily use deduction and deductive reasoning. It may not be appropriate based on the circumstances. I mean, here we have an example of scientific reasoning, which may fit the inductive pattern. The precise argumentation in science surely disputed, and the different analyses are given, but a possible analysis could be that this kind of reasoning in science is based on induction, based on past observations and then generalizing to a general rule here. Now, as good philosophers, we want to be able to classify inductive arguments according to their strength. We saw that when we were dealing with deductive arguments, it was useful to use the standard terms such as valid, sound, or invalid to discuss these arguments and to classify them and give some indication of their strength, their effectiveness, their properties. However, we don't use any of that vocabulary when we're discussing inductive arguments. So you would never suggest that an inductive argument is valid. You'd never suggest an inductive argument is sound. Those definitions just don't apply. There's a separate and different vocabulary that we use when we're describing inductive arguments, which is fitting considering the way they work. The key terms that we use typically are weak or strong. So we don't call them valid or sound, but as strong or weak. And there are ways we can distinguish the strong from the weak. So in general, we say an inductive argument is stronger if it's based on more observations and if it's based on more varied observations. These are the kind of things that make inductive arguments strong, as we'll see in some examples. And by contrast, we say an inductive argument is weaker if it's based on few observations and if those observations are not of much variety. We'll see this as it works in some examples in a moment. Another important thing to note before we go on to some examples is that when we're classifying the strength of inductive arguments, our classification is along a continuum. It's sort of a continuous range from the sort of very strongest and then slightly less strong again, perhaps even middling in terms of the strength of the argument, and then to somewhat weak, and then weaker, and then weakest still, perhaps even calling those ones that are so weak, worthless even. So it's sort of a smooth scale, and that's different to what we had with the deductive, where it's a sort of a yes or no thing. Is it valid or not? Yes or no? Is it sound or not? Yes or no? Does it fit or not? Yes or no? So a discrete sort of yes or no thing for the deductive arguments, whereas for inductive, it's sort of where does it fit on a continuous line? That's how we think of the strength when it comes to inductive arguments. So let's look at some examples now of inductive arguments and think about the strength of these. So here's one that could rightly call relatively strong. All ravens I have seen in 20 years on my scientific surveys across the globe are black, being the premise, and then the conclusion, therefore all ravens are black. This is relatively strong. I mean, it's backed up by 20 years of observation, many observations presumably during that time, we may say, and also it is varied across the globe, so that in different environments and habitats and so on, this person has completed these observations. So a large number of observations and varied observations. And we can contrast with this argument here. All ravens I have seen in Horsham, I have never left Horsham, are black. Therefore, all ravens are black. It's relatively weak. There may be different colour ravens just down the road this person has never seen, in Crawley, for example. Whereas the person who's been all around the globe, they obviously have a greater degree of backing in their case. So we can contrast these as a relatively strong and relatively weak inductive argument. So now to look at some final examples. If we consider this one, I wore my Chelsea hat for the first time on Saturday to see Chelsea play, and they won, being the premise. Therefore, whenever I wear my lucky hat to a game, Chelsea will win, the conclusion. Now, I'm sure you wouldn't take seriously anyone who put this forward. I mean, it is a relatively weak, perhaps even worthless inductive generalization. They are saying because they wore it once, and therefore surely at any time, any circumstance, it's going to happen again. It's only one observation. It's not varied at all. We sort of haven't controlled for any factors, and it's close to worthless as an argument. And by contrast, here's one that's about as strong as you can get. I did mention there may be some controversy about scientific reasoning and how it works, but we may say that one interpretation of how this reasoning process goes is that it is inductive. So to consider this example, considering all the billions of observations from across the globe, water has always been observed to boil at 100 degrees centigrade. Therefore, water always boils at 100 degrees centigrade. And this is relatively strong, perhaps as strong as you can get, pretty much, because it is true to say that the water has been observed across the globe to boil at 100 degrees centigrade. Of course, that atmospheric pressure on planet Earth. But that aside, this experiment is done in countless classrooms. It's often a first chemistry experiment, and in every situation, it has been observed to boil 100 degrees centigrade. Therefore, this seems very safe generalization to say that it always boils 100 degrees centigrade. So we can say it's relatively strong. So that brings us to the end of the video today. We've looked at the inductive argument, what that is, the definition of the inductive argument. We've seen how, in the case of inductive argument, its conclusion follows with probability, contrasting with the deductive argument, where at least the aim is that the conclusion will follow with certainty. We've also considered the general form of inductive argument, which probably on the A-level course should be considered part of its definition, this fact that it's a generalization based on past experiences. Seen some examples and how they fit that model. And we've discussed how you classify the strength of inductive arguments from strong to weak based on the amount of observations and the circumstances and variety of circumstances in which those observations were made. So I hope that was helpful. Any questions, queries, comments, opinions, please do leave a comment below, and also don't forget to hit subscribe for more A-level philosophy videos.
John Stuart Mill on his own free will, on half-pint shandy was particularly ill. Later they say could sing it away, half a grade of whiskey every day. Aristotle was a bagger for the bottle, Hobbes was fond of his dram, and Rennie Descartes was a drunken fart. I drink, therefore I am.